my TradeBot access to $100,000. Hey everyone, my name's Captain Flasky Boy, and for the past several weeks I've been building a TradeBot from scratch. We have finally gotten to the stage where the TradeBot analyzes individual stocks and generates a buy, hold, or sell signal. Most importantly, it doesn't trade blindly, only stocks rated by can trigger the purchase logic. But it couldn't trade. A TradeBot that can't trade is basically just useless. I was originally going to use Trading 212 because that's what I use personally. However, after consulting Chatbot and Gemichan, I opened an account with Alpaca. So why should I use Alpaca? Well, it's easy, that's why. Not only is it a developer-friendly service, the API is well documented and it's free to use on sign up. So let's sign up and see how it works. The first thing you will notice, we are on a paper trading account, which essentially means we are now playing a very advanced version of Monopoly. This is the Alpaca paper trading dashboard, where you'll find the typical things you see on any trading platform: positions, orders, activities, and balances. If we click into account, we can see exactly how much Monopoly money we've got to play with while testing everything out. Let's take a look at the documentation and the API. Now we've moved over to the Alpaca API documentation. And the first thing you'll notice is how clean and easy it is to understand. Not only does it explain each endpoint clearly, but it also lets you try the API calls live and even generates example code for you, which is perfect if you're building something quickly. Okay, let's actually use the service. If you look at the Alpaca API, it basically screams at you to use Postman, which is a great tool for getting familiar with new REST APIs and endpoints. So the very first thing I did was install Postman and use it to start poking the Alpaca API to see how everything works. Here you can see me using Postman to send a request to the Alpaca API and pull back my account details, which includes things like buying power, portfolio value, and trading permissions. This verifies that my API keys are correctly connected and that I can actually talk to Alpaca through the API. I then carried on getting familiar with the Alpaca API, using Postman to place buy and sell orders and see how trades actually work under the hood. From there, I moved on to creating and managing watch lists, which gave me an idea for stock TradeBot management later. Okay, after getting familiar with the various API calls, the next thing I like to do is create a series of microscripts. I decided to have ChatGPT generate the microscripts for me, because why not? These microscripts mimic the main actions I want to perform later in the project, and because they're nothing too complicated, it just made sense to let ChatGPT handle them. So, what do we actually want our TradeBot to do? First, we want it to be able to place orders buying and selling stocks on our behalf. We also want it to list all our active positions, which is simply every stock we currently own, and be able to retrieve the details for an individual stock when we need them. On top of that, we want the ability to create, add to, and delete watch lists. Watch lists are important because they help the TradeBot keep track of the stocks it's interested in and watching closely. Finally, we want the bot to be able to buy different stocks at the same time, so we can lock in prices without delays. Okay, writing scripts is fun and all, but let's be honest, nobody gets excited staring at a terminal. We want visuals, we want shiny interfaces, and we definitely want buttons to click and menus to mash like a proper control panel. To do this, I'm going to make use of my ChatGPT Universal Prompt template. I take that prompt, re-enter it into ChatGPT, usually in a dedicated working chat, and ask it to write the prompt for me. 9 times out of 10, this turns out to be the most efficient way to work with AI like ChatGPT.
In slang, gross means extremely disgusting, repulsive, nasty, or unpleasant. And I will not be cleaning that up.
After feeling like a human printer for the last hour, just endlessly outputting code, we finally have a working custom Alpaca dashboard. Let's take a look and see what this thing can actually do. If we take a look at the home page, you'll see all the same information you'd normally find in the Alpaca dashboard. We've got cash, buying power, equity, recent orders. And along the top, you'll see tabs for the watchlist positions, trading orders, and even a debug tab for when things inevitably go wrong. Here you can see me placing a market order and purchasing a share of Apple. I'm buying a single share using the AAPL ticker to test that everything is working end to end. Something I didn't notice until later is that the Alpaca API has a clock endpoint that tells you whether the market is open or closed. This is perfect for when I host my TradeBot, because it means the bot can automatically avoid trading when the market isn't live. So after all of this, let's reset for a moment and take time to think. Okay, so the goal of this series is to build fully autonomous, modular trading bots. But back in episode 5, we explored something slightly different. A fully AI prompt-driven trade bot. You could enter a ticker symbol into the trade bot, and it would fire back a buy, sell, or hold rating. It was pretty basic, but it got the job done and proved you could use AI to evaluate stocks. So what if we take everything we built and learned in episode 5 and push it a little further? What if we hook up the Gemini AI-powered trade bot to the Alpaca API and let it trade for a few weeks? So, in true developer fashion, I created a new project. I then proceeded to smush the Alpaca dashboard code together with the Gemini TradeBot code. Now that we've got all the important code merged into a single project, we can finally focus on what we actually want to build. The plan is to reuse or slightly tweak the Gemini AI prompt inside the decision engine so it can loop through our current Alpaca watchlist and spit out a clear decision for each stock, buy, hold, or sell. All of the core logic is already in place. We just need to wire everything together. So give me a second and let's make it happen. Let's launch the application and take a look at the first iteration. I've intentionally stripped out all the fancy CSS and kept the interface minimal, because the focus right now is functionality over visuals. We're starting on the homepage, which provides a quick account summary. At a glance, we can see the current trading mode, whether this is paper or live, plus details like available cash, buying power, and equity. If we click on watch lists, we get a list of all available watch lists. From here, we can create new watch lists, select an active one, and view the stocks it contains. We also have the ability to add new symbols or remove existing ones, giving us full control over exactly which stocks the bot will evaluate. There's also a debug section, which is useful for troubleshooting and verifying connectivity with the Alpaca API. Let's get the AI to evaluate and purchase some stocks. To start, we first select the watch list we want to run. Next, we specify how many shares per stock we'd like to purchase. I'll leave this set to 1. Once that's configured, we can click the button to evaluate the stocks and let the AI run its analysis. Under the hood, the bot evaluates stocks one at a time using live market data. For each symbol, it generates a buy, hold, or sell signal, along with a confidence score and the reasoning behind that decision. Every recommendation is explainable, and nothing happens without a clearly defined signal driving it. We can see that the AI trade bot has completed its evaluation and submitted an order for a single share of Tesla after meeting the required confidence threshold. At the same time, Apple and Microsoft were both given a hold rating, meaning no trades were placed for those stocks. The bot evaluated them, but decided not to buy or sell based on current conditions. To confirm that the Tesla order was completed, we can click on the Orders tab and review all recent trades the AI bot has placed. Each order is timestamped and includes a unique ID that links directly back to Alpaca. Of course, this same information is also available inside the Alpaca dashboard, so everything stays fully transparent and verifiable. Now that we have a basic running application, let's move on to hosting it online. Way back in episode 1, we have been talking about using Docker to deploy and run the TradeBot application, which is no problem. I've gone ahead and written a Docker file, and we can see locally it works. The only question becomes, how are we going to host it online? So I already knew I wanted to use a VPS. If you're not familiar, a VPS is basically a virtualized private server running on shared hardware. In other words, we're hosting this thing in the cloud. Originally, I planned to use Node. I'd heard nothing but good things about it, but for whatever reason, it straight up refused to let me sign up. My account kept getting canceled automatically, and I couldn't even reach a support team to prove it was actually me. So clearly, that plan wasn't happening. At this point, I honestly didn't know what to do. Reviewing a bunch of cloud platforms was not on my to-do list. I already knew I didn't want to use Google Cloud, Microsoft Azure, or AWS, but once you rule those out, what's actually left? Things were already taking longer than I wanted, so instead of overthinking it, I did what any reasonable developer would do. I asked ChatGPT to give me a list of VPS providers. After a quick skim, I didn't overthink it. I picked the first option on the list and moved on. According to ChatGPT, it was actually the most expensive option, but honestly, who cares? I needed to make a decision and keep going. Little did I know, that choice would turn out to be one of the best decisions I've made so far in this TradeBot series. Alright, let's jump in, sign up for DigitalOcean, and start putting this thing to work. Having never used DigitalOcean before, all of this was completely new to me. My original idea was to build the application around a Linux Docker container from the very beginning. The goal was to run a TradeBot in the cloud that could make decisions and access the markets 24/7. As I started looking into DigitalOcean, it became clear that I had two main options. I could either create a droplet, which is a full virtual server, or I could try a serverless function for a more hands-off approach. In the end, I decided to try both and see which one made the most sense for this project. So I started with following the function's Quick Start tutorial guide. When I started going through the Quick Start guide, the very first thing it asked me to do was install the DigitalOcean command line tool. You need it to build and test a Python serverless function locally before deploying to the cloud. Since I didn't really have another option, I went ahead and installed it and moved on. After installing the command line tool and verifying that it worked, I noticed a second tab called Control. From there, you can create a serverless function directly through the web interface. At that point, it honestly felt like I had wasted my time following the previous instructions. Here you can see me creating a new serverless function and setting the runtime to Python. After clicking Create, it opens a text box with a sample Hello World serverless function. Let's change it so it prints my name instead. Normally I'd walk through setting up a droplet step by step, but honestly, it's pretty straightforward. DigitalOcean does a great job of holding your hand and guiding you through the entire process. Now that we know how to create a serverless function and droplet, we can work out how this trade bot actually lives in the cloud. The big question is, how does it run on its own? Because the bot needs to wake up, check the watch list, evaluate signals, and decide whether to buy, hold, or sell without me manually clicking buttons. And the second question is even more important, cost. I'm not trying to build an enterprise system here, I'm trying to build a trade bot because I'm not rich. After some focused experimentation and a few rough prototypes, I landed on an approach that minimizes moving parts while staying as cost-effective as possible. If the web page doesn't provide any real value beyond displaying information, then it makes sense to move all of the core logic and decision-making into background Python functions. Those functions can be deployed to DigitalOcean as serverless functions and triggered automatically once, twice, or even multiple times a day, using DigitalOcean's built-in triggers. The idea is to split the system into a couple of focused components. A lightweight web GUI runs on the cheapest DigitalOcean droplet we can get away with, and a serverless function handles stock analysis, trade decisions, and all communication with Gemini and Alpaca over REST APIs. Now that we have a plan and we know what we're doing, I think it's about time to wrap things up with a coding montage.
Oh boy, a coding montage.
Okay, after that time lapse, you can see we've now built 5 serverless functions. Only 2 of these power the AI-driven trade bot itself. The remaining functions are dedicated to learning experimentation and sanity checking the system so it doesn't do anything stupid with real money. Let's check out the Gemini Serverless Sanity function. It sends a fixed AAPL price snapshot to the Gemini API using a tightly controlled JSON-only prompt, giving you a clear view of the kind of instructions we're sending the AI. The response is cleaned, parsed, and validated to enforce structure. If anything looks off, it fails fast. No trades, no surprises. Let's run this function and take a look at the output. When it executes, you can see Gemini returns a clear trading decision, structured JSON with an action of buy, a confidence score above 0.75, and a concise reason explaining why that buy rating was issued. Although, judging by the response, Gemini also seems to think I'm some sort of pirate. I also want to show you the Run Endpoint Sanity Check, a serverless health check function that verifies all external dependencies before any trading logic runs. It tests FinHub market data, confirms Gemini can respond via REST, and validates Alpaca account access. Each service is checked independently and returned in a single JSON response, giving a clear green or red status for the entire trading stack. While building these serverless functions, I hit a couple of very real problems. The first one was dependencies. DigitalOcean does ship Python 3.11 with a handful of pre-installed libraries, but crucially, it doesn't include Google's GenAI package. I did get it working by following the docs, but it quickly turned into one of those setups with way too many moving parts. So I scrapped that approach and rewrote everything to talk to Gemini directly over a plain HTTPS REST call. The second issue showed up as the codebase grew. Once you start splitting logic across multiple files and classes, object-oriented patterns actually make serverless development harder, not easier. Complexity goes up, iteration slows down, and debugging becomes painful. So I made what might be a controversial decision. I ditched OOP entirely and rewrote the functions as linear, top-down scripts. The payoff was huge. I can now read and edit the code directly in the web interface, create and tweak serverless functions without touching the command line, and most importantly, the execution flow is obvious. Less magic, easier debugging, and a setup that actually works with serverless instead of fighting it. Alright, now that the groundwork is done, let me show you the third iteration of the self-evaluating AI TradeBot. To demo this, I'm going to launch my second iteration of the TradeBot user interface. The user interface is essentially the same as before, but with almost all of the functionality stripped out, it can no longer create or evaluate watch lists. That responsibility now lives entirely inside the serverless functions. The web GUI's role is purely observational, not operational. So, following the flowchart we looked at earlier, the system is now split into two serverless functions. The first function is responsible for adding new stocks and tickers to the watch lists. This allows the TradeBot to independently track and maintain a list of stocks it's interested in, without relying on the user interface. The second serverless function iterates over that watch list, prompts Gemini to generate a trade decision, buy, sell, or hold, and then places the resulting order through the Alpaca API we set up earlier. Now, I'm going to be completely honest. We don't actually need a web interface at all. We don't need a GUI. We don't even need a droplet. These two serverless functions are doing all the heavy lifting, which technically makes this the cheapest cloud-hosted TradeBot ever built. But let's be real. Stakeholders and users don't care about systems they can't see. If there's no dashboard, did it even happen? So, after a few tweaks, let's check out iteration 3 of the web interface. Functionality-wise, iteration 3 is basically identical to iteration 2. The difference is personality. Version 2 was completely soulless, the kind of view only a backend engineer could love. So I fixed that by embedding a small pixel sprite version of Gemini-chan with a couple of buttons. It gives me something fun to look at whenever I'm checking what slightly unhinged market orders the TradeBot is placing. So far, we've built a self-evaluating AI TradeBot using serverless functions to track stocks, generate trade decisions with Gemini, and place orders through Alpaca, all while keeping costs as low as possible. If you enjoyed the build or learned something along the way, thanks for watching, and consider subscribing for the next iteration.